Thank you. My name is Gyebnar from Budapest, Hungary, the Semmelweis University, and I'm here to talk to you about our work with a novel approach to quantify differences between single patients and a group of controls throughout the means of diffusion tensor imaging. Just a few words about this MRI-based imaging method is that through the random process of diffusion, the random movements of water molecules in a cellular structure with a dedicated MR sequence, this microscopic scale can be measured with the millimeter scale measurement of MRI. If we fit an ellipsoid to this tensor data, this diffusion profile, we can calculate simple quantities such as the tensor eigenvalues to quantify the diffusion profile and its geometrical properties. And the general approach from this point is, throughout the literature, is to calculate like anisotropy measures and compare them on a voxel basis or even a higher level between subjects and between groups of patients and controls. But because of the difficult statistical problem of the single patient versus control group comparison, it poses such a significant problem to solve. So our approach was to take the diffusion eigenvalues from each voxel, create a three-dimensional parameter space from it, and use the three-dimensional Mahalanobis-distance as a measure of dissimilarity, as a distance measure between any given voxel, the point corresponding to a patient, the distance from the group of controls. After that, we just calculate which distances are significant, and we assume that these outlying points, so those voxels which can be considered to be outliers in a normal distribution, they correspond to pathologic regions in the brain. So first, we did some simulation study thorough simulation experiments to quantify and to find the optimal parameters to do this, best cluster size thresholding and things like that. And with this optimized parameter space, we could get to really specific results with a few patients. For example, here on the left side you see a patient with the right temporal schizencephaly, the left side of focal cortical dysplasia, just alongside with the results of another more common method. Thank you for your attention.